Hi, my dear students. I hope your preparation towards your NEET and KCET exam is going very well. Welcome back to the Anand Medical Academy YouTube classes once again. In this session, we are starting a crash course where we will be revising first PUC and second PUC syllabus, and we are starting with our second PUC topics. So let's start the first chapter, electrostatics. This is the chapter we are going to finish in 3 classes. And electrostatics is the chapter which contains 2 different chapters. The first one is electric charges and fields, and the second chapter involved in this unit, electrostatic potential and capacitance. So my dear students, have a look at it. This is the chapter which is having connection to your gravitation chapter in first PUC. Out of 45 questions in the NEET exam, carefully see. Out of 45 questions in the NEET exam, 1, 2, 3, from these 3 chapters, you can expect 4 questions directly or indirectly. Indirectly means sometimes there may be a question related to the dimensions from these chapters. Here there is a universal gravitational constant. Most of the years the dimensional formula of capital G was asked. That's called indirect way of asking questions from these chapters. And in these chapters, so there is a physical quantity called epsilon naught. Permittivity in free space. What is the dimensional formula or the units of permittivity in free space? Or what is the value of this permittivity in free space? Such kind of questions are indirectly asked questions. Directly or indirectly, all together you will get 4 questions from 1, 2, 3 chapters. So you should understand the importance of this chapter. To finish both electrostatics 2 chapters, when you are in +2, when you are studying second PUC, first time of these chapters, we have taken approximately 18 to 20 classes to finish these 2 chapters. Here, we are taking only 3 classes to finish these 2 chapters. That's called a quick revision on what areas you need to focus. On what areas if you focus, you will not leave the question out of those 4 questions in the exam. And those areas will be focusing. This is just a quick recap. And the previously, when we are doing 18 to 20 classes of these chapters, the major effort was from our side. Now, when we are finishing these 2 chapters in 3 classes, the major efforts from your side must be. Remember, my dear children, during your quick recap or short revision or crash course right now, whatever we are discussing, the major efforts must be from your side. So then only the productive result will come out. Alright? Let's focus. So the first chapter is electric charges and fields. And now we are starting with a simple concept called quantization of charge. So we are not going into the details of the quantization of the charge. Have a look at it. So quantization of the charge, I am writing a formula. Q is equal to plus or minus N into E. So what is this Q? This Q is charge on any body in the nature. Charge on any body in the nature. And what is this N? So this N is a number of electrons present in a charge. And what is this E? So this is a charge of an electron. Carefully see. So that's a charge of an electron. So this is number of electrons. Or exactly speaking, so that's a number of charges. Number of charges. So there are so many applications related to quantization of the charge. Especially for KCET exams, there were questions based on this. So they'll give some charge. They'll ask you how many number of electrons present in that charge. Charge of an electron, you know, 1.6 into 10 raised to minus 19 Coulomb. So this is the smallest possible charge in the nature, my dear children. This is the smallest possible charge in the nature. Remember. So this is the Q, for example, 2 Coulomb is given, which is equal to N, number of electrons present in this charge, into 1.6 into 10 raised to minus 19. You can find the N value. I'm not going to write further, because I told you the efforts must be more from your side. So this is what the N you find out. So in this way, the questions can be asked from here. Now, look at the interesting thing here. So there is a charge Q1 and there is another charge Q2. Both are separated at a distance R. You all know that according to the Coulomb's law, of force of interaction, I'm not saying force of attraction, force of interaction. So this Q1 will apply a force on this Q2 and this Q2 will apply a force on Q1. Understand? Listen, this Q1 will apply a force on Q2. This is the F. And this Q2 will apply a force on Q1, that is F, and this is called the force of repulsion here. For example, if this is a positive charge, this is a negative charge, there will be an attraction present over there. Now, this Coulomb's force of interaction is equal to F is equal to K Q1 Q2 by R square. Carefully observe. And this F is equal to this K value, I can write 1 by 4 pi epsilon naught into Q1 Q2 by R square. 1 by 4 pi epsilon naught into Q1 Q2 by R square. And you know this 1 by 4 pi epsilon naught value is 9 into 10 raised to 9 Newton meter square per Coulomb square. Very important expression. The value of 1 by 4 pi epsilon naught is 9 into 10 raised to 9 Newton meter square per Coulomb square. Now here epsilon naught, that is very important. And what is epsilon naught? I have told you already. It is 8.85 into 10 raised to minus 12 Coulomb square per Newton meter square. You know what is this? So this is what the permittivity in free space. This is the permittivity in free space. So carefully go through the units of it, because the question you may get it from the units. If you know the units, the dimensional formula, you can write it. Remember this epsilon naught. This is the epsilon naught in free space, my dear children. Epsilon naught in free space. In first PUC and second PUC, you might have learned about both gravitational force of attraction, Coulomb's force of interaction. I hope both of the things you have learned. Gravitational force is always attractive in nature, whereas Coulomb's force, this may be attraction or repulsion, depends on the charges, positive or negative. Whereas in gravitational force, the masses will be present over there, and the masses cannot be negative. It's always a positive. So that's the reason there is only attraction force between two masses, but there may be attraction or repulsion between two charges. So why I am discussing this is the gravitational force is independent of the medium present between the two masses. Whereas this Coulomb force is depending on the medium present in between the two charges. Listen, my dear students. The medium present in between two charges may be air or vacuum. The medium present between these two charges may be an insulator. The medium present between these two charges may be a conductor. All these three cases are possible, right? Okay, and coming back to this situation, my dear children, have a look at it. And this is what I'm writing here. F is equal to, okay, so I'll just write here, just have a look at it. So I'm just rubbing this part. Fine. So have a look at it. So this is the charge Q1 and this is the charge Q2. So we know F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. For example, if this is the medium is air or vacuum, this is the situation. For example, other than air or vacuum, if you keep, this equation will become F by 4 pi epsilon Q1 Q2 by R square. Epsilon means permittivity. Where is that? See here. Epsilon is the permittivity in the medium. Epsilon naught is permittivity in free space. I hope you are understanding. Okay. Now look at this. So there is a relation between this epsilon naught and epsilon. That is very important. And that is called epsilon R, which is relative permittivity. Relative permittivity is equal to epsilon by epsilon naught. And this relative permittivity, it's also called as K, which is called a dielectric constant. So this dielectric constant, about this we will be discussing more in the next chapters. And this dielectric constant, you have a very important values here. That is very important. So the dielectric constant can be 1. The dielectric constant can be greater than 1. And the peak value of dielectric constant can be infinite also. So this is possible in air or vacuum. And this is for insulator. And this is for a conductor, my dear students. Right? Okay. In the place of epsilon, what I can keep? So F is equal to 1 by 4 pi. So the epsilon, I can write the multiplication of these two. Relative permittivity into epsilon naught divided by Q1 Q2 by R square. So this is called the force of interaction when there is a medium present between the two charges. Understand? And I hope you also could remember the concept called the principle of superposition. Principle of superposition. Principle of superposition. So what is this principle of the superposition? Listen, my dear children. So there is a charge Q1 here. There is a charge Q2 here. Imagine this is the distance R, for example. Imagine at some point there is a charge Q naught is placed. This is the positive charge. This Q1 at a distance x, for example, at a distance x. This Q1 will apply a repulsion force on Q naught, that's F. Imagine that's F1. The force of interaction between these two charges. So what is that value? F1 is equal to K into Q1 Q2. According to Coulomb's law, K Q1 Q2 by R square. Q1, it's a Q1. Q2, it's a Q naught divided by R square. So this is a X square. And at the same time, this Q2 will apply a force F2 on Q naught. So what is that F2? So this F2 is equal to K Q2 Q naught divided by, so this is R minus X. What is this distance between the two charges? When it is X, the total distance is R. There is this distance R minus X. So I can write R minus X whole square. Right? Clear? So here there is a force acting in two different directions at this point. What is the net force at this point? So the net force at this point is the difference of these two. Understand? Net force at this point is the difference of these two. So definitely that will be F2 minus F1. So this is called the principle of superposition. Understand? So finding the net force due to all other charges at a particular point. That is possible due to the principle of superposition. And let's have a look at and different models of the numericals related to Coulomb's law. Understand and get ready now. So there are two charges of each q, small q. They are separated at a distance r. Exactly at the midpoint, there is a big charge, capital Q is placed. Now, what should be the value of capital Q for the system to be in equilibrium? Remember, the system is in equilibrium means the net force on this charge and the net force on this charge, net force on this charge means it's due to the other two charges. Net force on this charge must be 0. You take any case. And our aim is to find what should be the value of capital Q. Let's move on. I'm just taking net force at point A is 0. Net force at point A due to other charges is 0. Due to the other charges is 0. Ready? So, F net is equal to, see, there is a force of repulsion between these two and our focus is on this charge, small q. So, this q will repel this with a force F. Right? Let's take that is F1. And this small q, which is at a distance r from this another small q, there is another repulsion force, that's F2. You understand? So this charge will repel this. This charge will repel this. So the net force I can write it is F1 plus F2. So what is F1? It's a K F1 due to these two, right? K capital Q small q divided by R by 2 whole square plus K into, now the second force is due to these two charges, K into Q square divided by R square. So that is 0. Understand? This is 0. Okay. Now it's a 4K small q capital Q divided by R square plus K small q square divided by R square, that's equal to 0. Now here KQ by R square if you take common, so that is 4 into capital Q plus small q which is equal to 0. And this one 4q is equal to minus small q, and this one q is equal to minus small q by 4. Have a look at it, a beautiful concept of physics. So when the capital Q value is small q by 4 and minus small q by 4 here, if you keep a minus small q by 4, so that means if this charge is 4 Coulomb and this charge is 4 Coulomb, and what must be this charge? So this charge will be minus 1 Coulomb, such that the total system of charges will be in equilibrium. A very important and the very useful for your exam preparation, whatever may be the exam. So even if you write for JEE exam also, and there are chances and there are cases where this question was asked, direct question. Sometimes minus q by 4 is the direct answer, or sometimes like this also value can be given. So what is this q? Q is this charge or this charge. Step. Alright, we'll move to the next question. So we have less time and more syllabus to be recapped. So that's the reason we will be focusing more on the numericals instead of the concepts. So let us see Q and Q. Force of repulsion. So Q is, there is an ion here and there is another ion. Charge present on the ion is Q and Q. There is a repulsion force between these two. Those are the positive charges present. A charge of an electron is E, and find the number of electrons in each ion. Each ion charge is Q, and we know Q is equal to Ne. Whenever they say the number of electrons, you should use the quantization of the charge. So that's why we have discussed about the quantization of the charge. Now, so Q is equal to Ne. Students, this F is equal to K Q square, because Q1 into Q2 divided by D square. So this K I can write 1 by 4 pi epsilon naught into Q square by D square. Right? And this I can also write F is equal to 1 by 4 pi epsilon naught. This is N square E square divided by D square. You know, our aim is to find the number of charges. So from here I can write your N square value is equal to, see this N square is equal to, so denominator is E square and the numerator is 4 pi epsilon naught F D square. Simple. And N value is equal to square root of 4 pi epsilon naught F D square divided by E square. That's it. Options I have not given here, but according to the options you should pick it. If the options are in terms of K, so this is K, and what is this K? Is it the dielectric constant? Write it in the WhatsApp, my dear students. Write it in the WhatsApp. Write it in the WhatsApp. So can I say this K is a dielectric constant? Tell me fast. Can I say this K is the dielectric constant? Absolutely not. This K is just a constant which is having a value 1 by 4 pi epsilon naught. And all together 1 by 4 pi epsilon naught, what is that answer? That value 9 into 10 raised to 9. The units also you know. Alright? Clear? So this is how the numericals will be asked. And let's see some more numericals now. Right now. Let's see some more numericals. Pause the video, you write it and finish, and let us check the next question. Fine. Have a look at it. Look at this example. This is also most commonly asked question in all the entrance exams. So this is my x-axis and this is the y-axis. At a point a comma 0, right, there is a minus charge q is placed. At the same minus a comma 0, so there is a minus q is placed along y-axis. And this is what the origin. From the origin, so there is a point charge plus q is placed at a distance 2a comma 0. So that means it's 2a. Alright? Students, listen. So what I am not going to explain what exactly the question is. I'll explain the concept, then we'll sit into the question. Right? You all know that this is a because the point is mentioned from here to here. And this is also the distance a. I'm not talking about minus a plus a. It is like some 2 meters, it is also 2 meters. If it is 5 meters, this is also 5 meters. Alright? At this instant, carefully observe. So this is the line along which the force of interaction takes place. This plus q and minus q will attract each other, this you know. Minus q will attract plus q in this direction. And in the same way, this minus q also will attract this plus q. Okay? Fine. Listen. Imagine this is a force F and this is also the force F. They both are at an angle 2 theta. If this is theta and this also will be the theta. Carefully see. This is F. This F cos theta. And if this is F, this is another F cos theta. So that means 2F cos theta is in this direction. Good. Now listen, what I wanted to convey to you is, at this moment on this charge, net force acting is 2F cos theta. You all will agree with that? Definitely yes. At this moment on this charge, net force acting is 2F cos theta towards left side. So because of the net force, the body means this positive charge will move in this direction, reach to the origin. And at this point, due to inertia of the motion, already the charge is in the direction of in the motion at this point. At this point, of course, the net force will be 0, but still, as it is in the motion, it will move just slightly away from the origin. And at this instant, the same situation takes place. This is plus q, and at this instant, same situation takes place. So this will attract this. This will attract this. Again, the net force will be in this direction. How beautiful this is. Again, the net force will take place on this towards the origin. And in this case, the net force is towards the origin. At this point also, net force is towards the origin. So that means it will again comes back to the origin. Due to inertia, it goes further. Again, it will come back to the origin. Due to inertia, it goes further. It's like oscillation, right? So whenever this kind of question comes, remember, my dear students, so the charge makes oscillatory motion about the origin, and this oscillation, but not a simple harmonic. These oscillations will not be a simple harmonic motion, because simple harmonic motion condition is acceleration is directly proportional to minus x, where x is the position. This acceleration is always directly proportional to the minus x, or f is directly proportional to minus x. This is the condition for simple harmonic motion in this case, and this is not satisfied. Right? And why it is not satisfied? So that takes half an hour time to discuss. But you remember, understand, I hope you have studied this during your second PUC electrostatics NEET preparation. So you just go back and go through that. And let's move on to the next question. I hope you're understanding each and every line what we discuss here. And let's see the next concept here. Now, the next concept is most important for your all entrance exams. No word, no question, no line is unimportant here. Every line, every question, every word I speak is very, very, very important, and it will be helpful a lot for you as a quick revision of both the chapters electrostatics. Now, let's see this. So this is what a charge 1 Coulomb is present here. There is a charge 16 Coulomb is present here, my dear children, and it is at 10 meters distance located. And the question is, find the null point, my dear students. Null point. Null point is the point where the net force is equal to 0. Where the net force is equal to 0. And let's take, this is the null point at a distance x from 1 Coulomb. So this is the charge Q1 and this is the charge Q2, and I have told you the formula, the short trick. Those short tricks will be useful for you right now, as you're doing a quick recap, and those short tricks will be useful, and that x is equal to r divided by root q2 by q1 plus 1, and this r is 10 divided by root q2, it's 16 by 1 plus 1, so that is 10 divided by root 16, it's 4 plus 1, and it is 10 by 5, and it is 2 meters. Understand? 2 meters from where? 2 meters from the first charge, the equilibrium point. Andre, what is that? Null point will be there. And when it is 2 meters from the first charge, and this is absolutely 8 meters from the second charge. So read the options carefully. The null point they are asking from the first charge or the second charge. Identify carefully and you will definitely get the correct answer. Right? And let's move on to the next question. Some more questions. As I've told you, we have less time, maximum number of models and the numericals we have to discuss. Right? And this is what the concept from the principle of superposition. Have a look at it. So this is what an equilateral triangle where the charges Q, Q, Q is placed. Exactly at the centroid, there is a charge Q naught is placed. Exactly at the centroid. And you know, this is L, this is L, this is L. So from the vertex, from this vertex, this vertex, this vertex, the distance between any charge and the centroid charge will be L by root 3. That you know. L by root 3. By using simple mathematics and Pythagoras theorem, you can derive even. Anyway, of course, we are not going to derive it. Fine. So this charge will apply a force on this one, that is F1. This charge will apply a force F2 on this. See that repulsion. Nothing else. There is no logic behind that. Only repulsion. So this charge will apply a force on this Q naught, that is also F3. And can I say F1 is equal to F2 is equal to F3? Definitely I can say, because F1 if you find K Q naught by L by root 3 whole square. F1 K Q naught by L by root 3 whole square. F2 K Q naught by L by root 3 whole square. F3 also same. K Q naught by L by root 3 whole square. Everything is same. Okay. So now when, look at this. So you might have learned this in the vectors. Imagine this is 10 Newton, this is 10 Newton, this is 10 Newtons. On this body, see this is the body, there are 3 10 Newton forces are acting, and between any two adjacent forces, the angle is same. It's 120 degrees, it's 120 degrees, and this is 120 degrees. What is the net force on this charge now? So the net force on this charge now is 0, my dear children. Net force on that charge will be 0. So this is what the concept of equilibrium. In the vectors you might have learnt, and remember this, whatever may be the angle. So like this, it's a 0. The net force is 0. Now, let's see the continuation of this. Carefully observe. Observe. Charge Q here and charge Q here, and it's a charge minus Q here. Observe. And exactly at the centroid, children, look at here. Everyone focus. Exactly at here, the charge Q naught is kept. Right? Now, it is L, it is L, it is L. Same. This is L by root 3, L by root 3, L by root 3. Fine. Now the question is, what is the net force on Q naught due to all the three charges which are kept at the vertices of an equilateral triangle? Equilateral triangle, again I am telling you, okay, for your better understanding I am writing this is 60 and this is also 60 and this is also 60. Okay. This charge will apply a repulsion force F1, right? This charge will apply a repulsion force F2. Observe. This charge will apply an attraction force F3, my dear children. You got the point? Everybody. F1, F2 and F3. Right? What is the net force? Net force. Net force on what? Net force on this. Net force on this will be, there is a resultant of this F1 and F2. Look at here. Because F1 and F2 are at an angle, I am writing here, F1 and F2 are same and they are at an angle 120 degrees. And there is a resultant for this, that is F3 dash, and already F3 is in this direction. So the net force on Q naught will be F3 dash plus F3. So that's the answer. Right? You know how to find F3 dash. What is F3? This is the classwork. This is the classwork. So immediately you should solve this question and send me, my dear students, right now. Right now, not after the class. Just to pause the video and solve this question and send me the answer. When two vectors are at an angle 120 degrees and their magnitudes are same, you know what is the resultant vector. What is the resultant vector? So if you don't know it, so go back to your vectors and read it right now and come back to this question, solve this and send me immediately. Solve this and send me immediately, my dear children. Alright? Okay. So F3 dash, how much you will come to know, which is the resultant of F1 and F2, and F3 is already there between these two charges, resultant. So not the resultant, between these two charges force, that is F3. So those together you will get the answer, right? And one more application. As maximum as possible, we will be discussing the applications here. As maximum as possible. You get here? Another application is, there are two charged metal balls. So these are the two charged metal balls here. So same charge is given, both. They'll repel each other. You know, the next case is this one. So they'll repel each other. The next case is this one. So there is one charge Q here and there is another charge Q here. So this is the reference line, you know, from the initial position. So they repel at an angle theta. And the mass of this is M, right? So this is the wire or a string. Why they repel each other? Because Coulomb's force of interaction. On this there is a Coulomb's force F. On this also there is a Coulomb's force F. Right? Now, look at this. Imagine the system is in equilibrium. The net force on this will be 0. See? This is mg, this is F. And this is the tension T. And this is an angle theta. And it is T cos theta. And here it's T sin theta. As I've told you, net force at this point is 0. So then I can write F is equal to T sin theta and mg is equal to T cos theta, right? And if you divide these two, F by mg is equal to tan theta, and I can write F is equal to mg tan theta. If you know mass of the ball, each ball, and if you know theta value, you can find what is the force of repulsion between the two charges or two charged balls, identical ones. Right? So remember this expression, and I request everybody not to by heart the formulas. Not to by heart the formulas. It's not at all required. Hardly takes less than 10 seconds to draw this diagram, to identify this. Less than 10 seconds, I'm sure. That depends on your practice, my dear children. Okay, so F is equal to mg cos theta, mg tan theta, it's fine. And sometimes the question can be asked, what is the tension in the string? What is the tension in the string? So this is what I can write, square F, and this also you square and add, and right hand side also the same. So t square sine square theta plus t square cos square theta, and here f square plus m square g square is equal to t square, and from here tension you get it. So f square plus m square g square. All right, and this is how the concept of tension in the string can be discussed, can be identified. All right. So let's move to the next question or the next topic, right? See, motion of a charge in an electric field. Motion of a charge in an electric field. Motion of a charge in an electric field. Look at here. So first we should know about electric field and electric force. Electric field and electric force. So there is a source charge Q, and this will produce electric field surrounding of it. At a distance r, there is a point P is placed, and here there is a test charge Q0 is kept. This is positive and this is also positive. You know, there is a electric force will act on it, F in this direction. You know, so that force is equal to, listen, so E into Q. Carefully observe. That force is equal to E into Q, where Q is Q0. And from here I can write E bar is equal to F bar by Q0. Electric field intensity is equal to electric force acting on this charge divided by Q0. Now here E bar I can also write KQ by R square. Observe carefully. Here E bar is the electric field intensity, and this is not a small q, that's a capital Q, because electric field intensity is depending on the source charge, my dear children. Electric field intensity is depending on the source charge. So that's why it is KQ by R square. Right? So this is electric field due to a point charge, KQ by R square. And from here I can write E is inversely proportional to R square. E1 by E2 is equal to R2 by R1 whole square. Now, our topic is motion of a charge in an electric field. Imagine I have a positively charged plate here, positively charged plate. And there is a negatively charged plate is also here. You know how the electric field lines will be moved, you know already. So this is how the electric field lines will be moved. And electric field lines will always move from positive terminal to the negative terminal. That means, so the positively charged plate to the negatively charged plate. So for example, if I take a positive charge Q0, right? You know this is positive and there is a force acting on it is F in this direction, and that F already I have told you Q into E. And imagine there is a negative charge is placed here. So this positive will be attract this negative charge, and here also the force will be in this direction. So this case, so that F is in this direction, the other case F is in that direction. That you should take care. Okay. So whatever may be the situation, my dear children, listen. So in this way, I have an electric field where if I just place a charge there, if I just place a charge there of U is equal to 0, initially just a charge is kept there. We know V is equal to U plus AT and V is equal to 0 plus AT. Observe carefully. We have electric force. F is equal to QE, and this F I can write mass into acceleration, which is Q into E, and acceleration it will be QE by M, my dear students. You can expect a question from here. You can expect a question from here. Observe. So V is equal to acceleration. It's QE by M. It's QE by M into T. And if you know the velocity of this particle moving in an electric field, you can find the kinetic energy expression also. Half mv square. So that is half into m into v square. Q square, E square, T square divided by m square. So 1m and m cancel. This is the kinetic energy of the particle moving in an electric field. And you can also find S is equal to half AT square. So half into acceleration. So QE by M into T square. So like this, some expressions are very important. Motion of a charge in an electric field. In the same way, in the next chapters we will be discussing motion of a charge in a magnetic field also we will be discussing. Alright? Clear? Now, let's see the topic called electric flux. Let us see the topic called electric flux. I'm just rubbing this part. Have a look at it. This electric flux concept is very important to understand the next topics. To understand the next topics called Gauss Law. Electric flux. And direct formula I am writing, phi is equal to E bar dot A bar. Electric flux is a scalar quantity. That's why there is a dot product between two vectors. So this is EA cos theta. In some of the years, there was a question directly based on this. So E bar is equal to 2I cap plus J cap minus K cap. And A bar is given as I cap plus J cap plus K cap. So what is electric flux here? What is electric flux? Directly there is a dot product between these two. Making the dot product between these two. It's 2 into 1. It's 2. And 1 into 1. 1. Minus 1 into 1. Minus 1. So that is 2. Right? And what is the unit of electric flux here? Look at here. So this is a electric field and this is a area. Electric field. How can you get this? Electric field. So we know the formula. Electric field E is equal to F by Q. So that's a Newton per Coulomb. Yes or no? Newton per Coulomb. And electric field, this can also be written as volt per meter. Can anybody write in WhatsApp? How can you write electric field expression is V by M? How can you write the electric field expression is V by M? From what formula you write electric field SI unit is volt per meter? Just write it in WhatsApp. Write it in WhatsApp. Write it in WhatsApp. Just pause the video and write it in WhatsApp. Okay, so the flux units are, electric field units are Newton per Coulomb and A is meter square. So Newton meter square per Coulomb. This is what electric flux value. So this is electric flux value. Now, so one more point, let's move on. Very important, from this example, you can solve whatever may be the question related to the flux. Whatever may be the question related to the flux. And before going to that question, and what is this theta here? This theta is angle between E and A, right? What is the theta here? This theta is an angle between E and A, right? Yes or no? Yes. 100% it's S. Now, I'm just taking a cube. Listen, children. I'm just taking a cube. Just taking a cube. So this is what? The cube. So the electric field lines are moving like this. It's E bar. Direction of E bar you can see. The uniform electric field lines are moving like this. The uniform electric field lines are moving like this. Right? So the question is, find net electric flux linked with the cube. So cube will be having 6 faces. This is the front face, observe, and the back face. This is the right face, the other side is the left face. And this is the top surface and the other side bottom surface. Right? Like these 6 faces it will be having. Let's talk about flux associated with front face of the cube. Electric field into area vector into cos. What is the angle between? This is the front face, let's talk about. So this is the front face, my dear students, front face. What is the angle between electric field and area vector? So area vector direction is always away from the surface. If this is the surface, away from this surface is area vector direction. So that is 90 degrees. See, E bar is in this direction, area vector is in this direction, 90 degrees. So this is 0. And in the same way, flux linked with the back surface is also 0. And now you finish this. Flux linked with the left part, the left face. Left face through which the electric field lines enter. Flux linked with the right face through which electric field lines leave. Flux linked with top surface and flux linked with a bottom surface. Identify all these fluxes and add all of them. You get the net flux, my dear students, and just write the answer. I need the answers for everything. This answer, this answer, this answer, this answer, and all together I need this answer also. So neatly write it and take a photo and send it in the group. You all must be active in the group. I'm telling you, so this is the time, whatever is left for you, almost 30 days are most crucial part of your preparation, and Anand Medical Academy is helping you in this tough time by making a program like the revision and exclusively, and this is the program for our students. Understand? And do this and send me, do this and send me. And let's continue the last topic for today's session. Let's continue the last topic for today's session, which is electric dipole. Electric dipole. I'm just rubbing this. Now the topic of interest is electric dipole. So there is a minus Q charge and there is a plus Q charge here, or So there is a minus q charge and there is plus q charge here. So they are separated at a distance 2a. You know, electric dipole will have dipole moment, right? You know, this dipole moment is denoted with the symbol p bar, which is equal to 2a bar into q. Observe. So the magnitude, if you write, it will be 2aq. So electric dipole moment is the product of distance between the two charges and the magnitude of any of the charge. Dipole means equal magnitudes of the charges and opposite in the sign. So this is minus 2 Coulomb, Andre, that must be plus 2 Coulomb. That's a dipole, right? Now, it's 2aq, it's a dipole moment. And dipole moment is always directed from negative charge to the positive charge. The same things we will also be discussed in case of magnets. There is a magnet which is having south pole and north pole, and observe here. Here also there is a magnetic moment. There is a magnetic moment. So which is always directed. That magnetic moment is denoted with the symbol m bar. That's directed from south pole to the north pole. Directed from south pole to the north pole, my dear children. Alright? Clear? Now, so we need to discuss two important things related to the dipole. So imagine this is what the midpoint of the dipole. From the midpoint of the dipole at a distance r, so there is a point P is kept. At this point P, electric field we are going to find. At this point P, we are imagining that there is a charge Q naught, test charge Q naught is kept. This plus Q will apply an electric field in this direction. Electric field intensity, kq by r square. This minus q also will apply a force on this, that's a E2. You know, on the axial line, the electric field due to a short dipole means, so this is very small. So axial line, that will be 2 kp by r cube. So that will be k is 1 by 4 pi epsilon naught into 2p by r cube. So this is axial line. And you see the net electric field on the axial line point. So that is E1 minus E2. So because E1 is greater. So dipole moment is in this direction. So minus Q2 plus Q. And net electric field is also in this direction. Net electric field also in the direction. Remember, always in case of axial line point, net electric field will be in the direction of the dipole moment P bar. P bar and net electric field bar directions are same. So from the center of the dipole at a distance r on an equatorial point. See, on an equatorial point is the interesting thing. So E equatorial, which is equal to, you know, it's a kp by r cube. So which is 1 by 4 pi epsilon naught into p divided by, this is p, divided by r cube, kp by r cube. So what is that? This minus q and q naught are at this distance. And you know, this minus q will apply a force or electric field E1 in this direction. And at the same time, so this plus q will apply an electric field E2 in this direction. They are at some angle. And the net electric field will be in this direction. That is what? E equatorial. E equatorial. So this is E axial. And this E equatorial is always directed opposite to the direction of the electric dipole moment. Electric dipole moment is in this direction, minus Q2 plus Q. And whereas at this point, equatorial point, electric field will be opposite to the direction of the dipole moment. And there is a relation between these two, we get it, right? So there is a relation between these two, we get it. And most of the cases, so the question they have asked in maximum entrance exams was about short dipole, and that short dipole only we have discussed so far. That short dipole only we have discussed so far. Now, so there is a relation you will get from here, right? So what is that? So E axial divided by E equatorial. So what is this? So 2 kp by r cube divided by kp by r cube. So that is 2. So from here I can write E axial is equal to 2 times E equatorial. Superb. Right? Sir, it's a minus q and it is plus q. Now this is what the midpoint of the dipole. 2a is the distance between two charges, equal and opposite. At this point, what is this dipole? That's a question. At this point, what is the dipole? Because your p bar, right? And this is the point P. You can see this is R at a distance R, like that. So there is an angle between them is theta. Observe. At any theta, if the point is on the axial line, that theta is 0. If the point is on the equatorial line, that theta is 90. So my dear children, have a look at it carefully. At any point, if you want the dipole, electric field due to the dipole, so the formula will be kp by r cube square root 1 plus 3 cos square theta. Observe. Observe carefully. kp by r cube square root 1 plus 3 cos square theta. The same electric field due to the dipole, electric potential due to the dipole also we'll be discussing soon, the next chapters. So this is the electric field due to the dipole at any point. At any point. Just substitute your theta values, you will get it. In this case, theta is 0. In this case, theta is 90. You will get these answers only. The same answers you will get it. 2 kp by r cube and kp by r cube, you will get it. Alright, and let's see what kind of numerical can be asked. The last numerical for today's session, listen everyone. There is a Q and there is a Q. Imagine it is an equilateral triangle. It's a 60 degree, 60 and 60. And here it's a minus 2Q. The question is, find the net dipole moment of the system. Find net dipole moment of the system. Beautiful and important question. Find the net dipole moment of the system. So just pause the video and just rubbing this and do that. Net dipole moment of the system. Net dipole moment of the system. Get ready, get ready. Net dipole moment of the system. Have a look at it. So where is the dipole exactly first? Dipole andre enu? There must be a positive charge and negative charge of equal magnitudes. There is a positive charge, there is a positive charge, there is minus 2Q. And this minus 2Q, I can divide it as minus Q and minus Q. Okay? Is it okay so far? Alright. And this minus Q and minus plus Q, there is a dipole is formed here. Whose dipole moment is P1 bar, like this. And this minus Q and this minus plus Q will have another dipole, that's P2 bar. And P1 bar, P2 bar magnitudes. What is P1? P1 is equal to, so this is, imagine this is A and this is A and this is also A. Equilateral triangle of side A. Okay, so it's A into Q. And P2 is also A into Q. P1, P2. And now the resultant they are asking. What is the resultant? So this is an angle 60 degrees, my dear children. The resultant is like that. So this is the net dipole moment. And you know, the resultant is equal to square root P1 square plus P2 square plus 2 P1 P2 cos theta. Right? Clear? Theta 60 degrees. So you can apply this. So P is equal to root P1 square. It's a AQ whole square plus P2 square. AQ whole square plus 2 into AQ divide into cos 60 degrees. Okay. So P is equal to square root AQ whole square plus AQ whole square. So what I can write here? So AQ whole square if I take common. So this is 1 plus 1 plus 2. See here. 2 plus 2 cos 60. It's 1 by 2. Observe carefully. 2 gets cancelled. 2 plus 1, 3. So this is 3 AQ whole square. When AQ whole square comes out, so the net value is equal to AQ into root 3. So this is the answer. This is the answer. So if it takes more time, my dear students, and remember, so this value and this value same. When two vectors of same magnitude at an angle theta, then the resultant, if you want to find out, it will be 2p cos theta by 2. Remember the formula that you will derive from here only, from this formula only. When two vectors of same magnitude, it's 20 newtons, it is 20 newtons and they are inclined at an angle 60 degrees, for example. ಇದಕ್ಕೆ ನಿಮಗೆ ರಿಸಲ್ಟೆಂಟ್ ಬೇಕಂದ್ರೆ ಈ ತರ ರಿಸಲ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ is equal to 2 into p magnitude of individual vector. So what is that? AQ into cos theta by 2. So this is cos theta is 60 and theta by 2 is 30 degrees. So the resultant value is equal to 2AQ into root 3 by 2. 2 gets cancelled. Root 3AQ. Here root 3AQ and here also root 3AQ. Okay? Clear? So this is how this chapter will be discussed, my dear students, and this not this chapter. So there is only one concept is left called Gauss Law. And in Gauss Law, there are some expressions and there are some graphs will be there. So that will be discussed in the next class. Gauss Law and electrostatic potential will be discussed in the next class. And the last class of electrostatics will be discussing about capacitors. And if possible, capacitor and resistors together also we can discuss, my dear students. Okay, all right. Thank you so much and all the very best. And there will be 10 very important questions for your exam today. Right? In the evening. 10 important questions from our discussion. Only from our discussion. So all the very best. See you tomorrow.